not our product, that is one of the use case. So this is on the basis of the AI-driven solution that where we are using the multiple tag-based recommendation system where tags are context aware. So we are the team Abhishek, Bandhavi, and Vaishnavi. So we are going to explain first how the multiple tag-based system works and where the tags are context aware. So how many of us are aware that on the day-to-day basis we use the recommendation system in different applications? Wherever we talk about, we use the recommendation system. It's almost everywhere. But there are some problems with the traditional recommendation systems which are available. For example, for the last 2 decades, we see for e-commerce or the grocery or the dating apps, wherever we see there are applications of it. But sometimes they are not personalized. Even for example, if you go to the Netflix, we know what we want to watch based on our history. It recommends us some movies, but sometimes we still end up scrolling 10 to 20 minutes to see what we want to watch. So that means there's a gap. If we talk about the dating apps, so we scroll here and there, but sometimes we don't find the correct match. Grocery, we talk about anything, there is a gap in the solution in terms of the personalized solution, in terms of the recommendation system. So that's where our solution comes in, where we are using multiple tags, and the combination of those tags will be working as giving the more context. Next. Yeah. So as you can see here, the multiple tags go into one cluster. For example, let's say for the Netflix. So generally how we get the recommendation system, recommendation on Netflix, it could be either based on the ratings. If we are watching some movies, let's say 3.5 and above, it will suggest those movies. If we are watching movies from a different country, it will show us those. What if we are watching movies on different genre, it will show according to that. But what if we want to see more personalized movies? For example, if I want to see a horror movie from a particular country that is based on solely on my experience. So that kind of solution is missing. So that's where what we try to do is we take different tags from different kinds of solution. For example, it could be meta tags, it could be directors, it could be actors, it could be anything. And we create a bunch of cluster out of it. So now that one cluster is context aware. It's personalized, it's more accurate, and it can give you the data-driven solution. So that's how the cluster will work. Okay. So once we have that cluster, we are using different things. At the back end, for example, we are using per topic, we are using the NetworkX that my team is going to explain.
When it comes to NetworkX, firstly, while we're talking about clusters and how we want to divide our clusters, we did try different techniques, like we did try Word2Vec, and we obviously used TF-IDF, but we realized it's not actually clustering the tags according to the way how we want. And most of the clusters didn't make much sense. And that's when we tried using NetworkX, and it made much more sense. Like clusters are like, it says comedy, it says humor, and it says fun. So all of these are mostly into the same cluster. And when we choose a movie, if there's any of the tags that already have any of these tags already associated with them, so we have mostly personalized movies that we get. And then we do the cosine similarity between the tags, and that's when we apply the graph, and then we have the clusters divided, and then we form the nodes for it. And this is the whole idea. This is mostly the architecture of how the NetworkX works. But we realized there are better technologies that we can use. That's when we plan on using per topic, and that will be explained by Vaishnavi.
Hi everyone, I'm Vaishnavi. So we came across one issue when we were using traditional NLP techniques, that was not identifying context very clearly. For example, let's say, so what the Hootsuite that we mentioned, it's basically a neighborhood selection app for students who have just entered in Chicago. So that is one of the use cases that we have considered. So considering students, a lot of them are Gen Zs. And there are tags like too many rich people, no cap. And that would not be identified by any regular NLP algorithm very easily. It would just consider cap as a separate word and then would make a mess out of it. And that is where we thought of using a transformer-based model, which is word topic that we have used here. So what word topic does is, instead of using regular clustering, it uses HDD scan, and then it has its own embedding techniques, where it embeds based on several contexts taken into consideration. Like a particular place could have tags such as multiple tags. Like some people might like it, some people might not like it. Some people might say this place has too many clubs, not for me. And some people will just say that, oh, this is a very happening place. But it all boils down to the same thing. And to understand that context, we need something like a transformer model, because attention is all we need. And that is why we have gone ahead with it. And when we tried clustering using word topic, the clusters seem to be more seamless, because a lot of words that would not be identified regularly were all clustered together based on context. And that is how we got better clusters. We do have the code for it. Yeah. Yeah, so there were a lot of things. This is a very simple one because we used a regular movie lens data set. We do not have a lot of tags for places, but it identified clusters very clearly, and that is how we think that this model could be a game changer in the field of recommender systems. And as far as the use case is concerned, we have a very simple UI, because we were not more focused on the UI part of it, we were focused on the solution part of it.
Yeah, and these are some of the solutions. For example, healthcare. So we have a recommendation system, but sometimes it doesn't consider if you are allergic to something, or we have the thinness, or we have blood clotting. In kind of finance, it doesn't consider all these kinds of things. So in this approach, this algorithm, in terms of API, it can get access to any kind of data set, and it can give us more traditional and more customized, personalized solutions which are not available. So there is a heavy use of Redball and different things at the back end. So we'll give a simple application that is available there. So the hood application. So
this is a very regular application, since we are talking about students who just entered Chicago. And like these are the 4 popular universities here. Let's just take the call. And these are the neighborhoods that they could reside in. And then clicking on them, we could enter tags for these, and all those tags would be stored. For example, let's say a very calm place. You could upvote or downvote it. Based on upvoting, the size of that tag would increase. This is something like a fun way for them to interact. And this is also our data collection. Based on these tags, we are going to collect data and then use the word topic model in order to cluster them in a context-aware way, and then make the recommendations more personalized.